I am from Osaka University. My name is Wataru Mizukami, and I'm in charge of the quantum computers. And we would like to present the Industry Academia Collaborative R&D and Quantum Software Research Hub. And the first half of this presentations, and we would like to introduce the research hub for the softwares as well as for the chemical areas. And I would like to discuss about the applications for the quantum softwares. And I'll be starting beginning. And at the latter part, Mitarai-san, who is a colleague, and who will be discussing about the applications for the finance and other areas. And now, some of you are not familiar with the Industry Academia Collaborative R&D and Research Hub. And this is the EQIH, and this is a quantum technology innovation, the basis. And quantum computing, and then also the sensors 2.0 in technologies that Japan is promoting this. And this is the hub for this. And approximately, there's 10 the locations or the are involved. And we are from Osaka University, and we're the one of those. And as you see the names, and this is a quantum technology innovation hubs, and this is the R&D the center to develop do the research for the quantum softwares. And as you see, JST and COI Next program, and that what we are receiving as a support. And let me discuss about the Quantum Software Research Hub and what we are doing at the QSRH, which I would like to talk about. And there's many the softwares involved in here. And for example, the middleware for the QPUs, and also you'll be able to use it with the cloud systems, and then also the for error detections algorithm, and that's all included, as well as the software development for the quantum computers, and also using the quantum softwares and what is going to be the solutions for the social problems and materials areas, and also other types of applications. And we are now developing the softwares that covers many areas. And there's 7 the issues that we are trying to cover. And as you see here, and in my presentations, and I would like to focus on my area, material, challenges for the material, and then also Mitarai-san's area is going to be for the financial, and as also which I would like to talk about, including machine learnings. And let me talk about the research project on the chemistry and materials and physics. And in terms of the objectives, is that building software library for the material science and develop that softwares for that. And we can use the other type of the software, such as like a VQE algorithm can be used or realized. And however, the quantum computing and very complicated the calculations, we cannot use that with some other softwares, and we need more sophisticated softwares to tackle those the calculations. And we are now working on that, developing such algorithms. And those are the main members at the Osaka universities. And beside myself, and I am in charge of the chemistries, and Professor Ueda, and the materials and the compound, and also Otake Mori-san and Inoue-san and Yoshida-san, and those are my colleagues for the research. And my team, and this is one of the softwares that we developed, and which is a Chemiclux. And using that quantum computing the chemistry, the areas that we are researching, and software to research the chemistries. And there's many different types of softwares as well. But one of the libraries' uniqueness is the QRD parts, which Kinesis is developing, and agnostic of the platforms, and also the less overhead, and therefore that's faster than others. And integration with the classic computing, and that's what we're trying to realize, so that we will be able to calculate a more practical way. And this is alpha version, and this is a simple one. And however, at the GitHub, and it's been published already. And one of the example would be, and for instance, within the liquid, and there's many reactions, and therefore we fuse with those the examples, and that is shown in this the photographs and the algorithm. So agnostic from the platforms, and also we focus on the speed, and this is that the kind of versions, and high performance computing merit is used in here, and multi-node and using that multi GPU with the accelerations, and we'll be able to research more efficient ways with this kind of softwares. And one example would be, and this is the parallel efficiency of the expected value calculations, and we developed such the quantum the circuit, and with the Teranisis-san and Hiraoka-san, and who developed this algorithm, and ADE GPU with one core, one node. The 8 GPUs with one node, and then also the 4 node, 32 GPU. And in that case, it's 60% that has been achieved. And with one node and 8 GPU, 99.6% is achieved. And for this can be used for the subroutine efficient implementation system. And we're using that NVIDIA's product at the backend. And beside this, and this is the classical computing, and that has been evolved, and it is important to integrate with that. And for example, at the large scale calculations with the quantum algorithms, and this is the look at the water simulations, and the 10 pico or so, and we'll be able to simulate like this. And the other the example is that high precision calculation is available, and there's some restrictions. However, with the classic computers, and we'll be able to do that CCS cap D, as you see here, and more like flexibility or the freedom is maintained in here. And therefore, you'll be able to use an infinite qubit, and we also will be able to use that kind of the method and the chemical area. And we'll be focusing on that, the other type of the simulator, which is a quantum spin simulator, and Ueda-san is developing this, and this is a QS cubic software. And with the just a regular simulator, in that case, and even though using the up to the 50, and that is the emulation limits, and but with several conditions, and you'll be able to calculate with the up to the thousands or so, and at the very top, and these are the plans, and we would like to accelerate the development and be able to utilize for the quantum development for the materials with the quantum softwares. And we also collaborate with the DIC and other companies. DIC is manufacturing many different types of the products, and we can contribute with our the quantum algorithms, and we are testing now. And although we don't really have that much the research outcome yet, and with the quantum computers, and the chemical the calculation will be more advanced than with the classic the computers. And we are now doing the joint project to find how much advantage that we can actually get compared to the classic ones. And this is another one, which is with the Toppan and the know-how for the products. And then also we have the know-how for the quantum algorithm. And with that, we are focusing on the more practical, something that can be used in the actual chemical the research. And we are now we would like to validate whether we can use that quantum algorithm at the site or not. And after here, I will be finishing my part, and I would like to introduce Mitarai-san, who is my colleague. From Osaka University, my name is Mitarai, and I would like to cover using the quantum computers. I would like to discuss about the machine learning and also application for the financial industries, which I would like to cover in my presentation. And first of all, and this is an overview, and I am a leader in this research, being a software and a library for quantum machine learning and mathematical data the science. And we are organizing the libraries, and that's what we are doing. And these are the members, and myself, and those are the main members, myself, and Mori-san. And Mori-san originally was a expert in the classic programming, classic computings. So he's very strong in the classic programming. And Miyamoto-san, and who is also a member, and originally, and who has the background in the physics. And however, the constant that he was engaged in the financial industry. So he also understands the finance as well as the quantum. So we have a very strong the members. And what we're doing mainly is this. And Scikit-Crack's library has been developed, and machine learning is used. And on a simulator, we verify what is library. That's what the QLAX is. And with the simulator, in terms of the machine learning, and there's many different types of algorithm, and what is the accuracies, and it is difficult to use the data set to test it. However, in a simple manner, you'll be able to test it. And as a library of the machine learnings, and this is quite popular. And our basic algorithm is in here. And the scikit-learn here, and this is a very simple interface by building upon our famous scikit-learn libraries. And so you'll be able to test it. And that is the concept. And examples are shown in here. And with the shoulder code and only like a 3 lines. And the data set row is excluded. However, the 3 rows and those kind of the image, it can be categorized. And this is the accuracy that you can get, and you'll be able to test it. And this is the algorithm included, and these are typical ones, and the neural the network, and then also the quantum kernel method, and those two are included, especially, and the machine learning, quantum machine learning, and then also using that quantum the circuit with the parameters and the data. Quantum data is embedded, and then like a neural network, and we can use that circuit, and then create the model for the machine learning. And that algorithm is embedded here, and that the circuit, quantum circuit, would be. It's pretty difficult to go through all those the papers. However, we'll be able to find the more prominent the quantum circuit, and that is included so that it's a usable the circuit, and you can select. There's several of the options, and you'll be able to find the accuracy is going to be this in case of this, and you'll be able to test that. And another topic is for the finance. And we don't really have the organized library yet. And algorithm for the finance, and we are developing that. And that is the main purpose, and especially in the finance area. And what we use this is that Monte Carlo simulations and the stock price changes in this way, and then also depending on the fluctuation of the stock price, and the option price has to be started, and what kind of portfolio we should have to get this type of the risks, and you will be able to use that Monte Carlo, and with the you can simulate that, and you'll be able to test the portfolio. And with the quantum algorithm, and you can reduce that required number from n to root n, and that is already known, and you'll be able to use this and build the algorithm for the finance. That's what we do. And one of the example is here, and quadratic speed up of the early exercise option pricing. And you can use this algorithm and compared to the classic computers, and it's faster. So the calculation volume was n and can become the n root n. So that kind of algorithm that we develop. And algorithm for the finance, and we use the Monte Carlo simulation accelerations, and that can be used in many different areas. For example, one of the applications that would be the application in the data analytic, the gravitational wave experiments. And we can use this algorithm for this. And we have already presented this. And bioinformatics application, and such as like a DNA and those kind of patterns from DNA sequence, and you can try to find the specific patterns, and you can use this, and something like a Monte Carlo simulations for different patterns, and you can get the specific patterns, and with the quantum computers, and n becomes a root n with the quantum computers. So we are utilizing that properties. So, and algorithm for the finance, and those the basic technologies for the finance is used for the other applications, and we'll be able to increase the numbers of the applications in this way. And this is the challenges that we're facing, and of course we have the joint project with the other companies, and those are the one of the examples, and one is a KDDI project. And we have already made an announcement on this. The noise compensator in optical communications via the quantum machine learning. And the noise is included in the signals, and that can be recovered into the noise, less noise signal. And that was one of the outcome, and already we have made it public. And another example is with the Nomura security company. And the quantum-inspired tensor network is used, and the stock return predictions. And with this portfolio, what is going to be the outcome? And whether the quantum would be better, or the classic would be better, or the classic inspired, or the tensor network would be better. And that's what we've been the testing. And there's a paper for this. If you're interested, and please read that, or please let us know. And at the very end, I would like to introduce this, and this is a summary, and with the QSARH, and we covered about all those projects that we are doing, and at the very top, and that is the application layers, and what we are doing, which I have talked about it, and myself and Mizukami-san, and this is what we are engaged with, and we talked about the machine learning and finance, as well as the chemical areas, and also I have talked about the other type of the algorithm that we are researching. And for the others, if you're interested, and please talk to us, or please go to our the company's website, and please contact us. And we do have a lot of project going on. If you're interested, and please contact us. Thank you very much.